there, scientists. Today, we are going to investigate earthquakes. You are going to be able to define liquefaction, and you're going to model what happens during liquefaction. So obviously, we have a new word that we're talking about today, and it's liquefaction, and we'll start to understand it as we get through this. Have you ever heard of the term quicksand or seen it in a movie? What do you think quicksand is? From movies that you have seen or childhood fears that I remember, because I really worried about quicksand. What happens when someone steps on quicksand? You may know that from movies or you've seen things on television that a person may sink into the sand, like it sucks them in. So why do you think that happens? Yeah, you're exactly right. There's a pressure change in the wet sand that results from a person stepping on the sand, changing it from a solid to a liquid-like substance. So quicksand and liquefaction actually have a lot here in common. And so you are going to be doing an investigation today where you're going to demonstrate liquefaction. So if we look at our text here and we read through this information, and so we have this background knowledge as we start to explain our process of our investigation. So how can you demonstrate liquefaction? During earthquakes, many buildings have collapsed or tilted and sunk into the ground. Why? Often the buildings were built on loose materials such as rocky soil, sand, or mud. There is also a lot of water in the ground. When the earthquake shook the ground, these materials became liquid-like. The change of a solid area of ground, such as sand or mud, into a less stable liquid-like condition is called liquefaction. Liquefaction is one of the hazards caused by earthquakes. In this investigation, you will use a model to learn how earthquakes affect structures built on sand or mud. So, as you jump into this investigation, you are going to be replicating what happens when land becomes unstable after an earthquake and liquefaction takes place. So what's going to happen is the first thing you need to do is you need to gather your materials. So you're going to need some sand, you're going to need some water, you're going to need a wooden block or could be a brick. You're going to need some structure that can represent a building. A plastic pan. You can use a plastic pan. You can use a tin pan. You can use a metal pan. Please do not use glass. And then you're going to need some type of a mallet or something that you can use that will not break or damage your container, but will be able to move it and shake it. So you gather your materials, and then you're going to try to make a prediction, okay? So think about, what do you think is going to happen what do you think is going to happen as you go through each step of this experiment? So you gathered your materials. Do you think that you're going to be able to replicate liquefaction with just these simple items? Now, in step one, the first thing you're going to do is you're going to fill the pan with sand, leaving about 9 centimeters to the top of your container, okay? Now then, after you get your pan filled, we want you to give that thing a good shake. Shake it side to side. Now, why do we want you to do that? Well, we want you to level out the sand. We want that sand to be level inside of there, so there's not too much at one side or the other. Next up, you're going to place the pan on a table, then pour water to just below the surface of the sand, and then record your observations. When you add the water, we want you to pour it slowly so that you don't make a giant hole in the sand, And we also want you to move your water pitcher around your container to slowly cover the sand. In all areas so that there's not too much water at one side, okay? When you do this, remember, you do not want water on top of the sand. It should be just below the surface. And then what does it look like? What do you notice here? Again, you can give that thing a quick little like side-to-side shake just so that everything stays level and kind of washed out. Next up, what you're going to do is you're going to push one end of your block down into the wet sand so it stands up like a building. Now predict what will happen when you repeatedly tap the mallet against the pan, and record that prediction. So what's going to happen here is we're getting ready to replicate our earthquake, where we have our building here. It's in this seemingly solid surface where it's standing straight upright, and really press that thing down in there. If you have to like shake it in a little bit so that it stays upright, do that. And what we're really thinking here is like, yeah, does this seem stable? And we want this to be stable. So what might happen when we gently shake this pan back and forth? Now that gets us into step 4. Hold the pan in place. Very gently, which means lightly, tap the side of the pan repeatedly with the mallet. Observe what happens to the sand and block and record your observations. So you're just tap, 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 tap. And you might have to give it, 50 to 100 taps. So you're just going to keep tapping it and you're going to watch what is happening inside of here. Make sure that you do this gently and repeatedly with the mallet on the side of the container, okay? You will notice changes in the sand and in the block as you continually tap it. We need you to record those observations. And especially want you to record those observations because what happens with your block may be totally different from what happens with a classmate's block. And we want to be able, as scientists, to compare our experiment and our data in order to better understand this phenomenon. Like, did everyone in your class, did the wooden blocks react the same way? And if not, why didn't they react the same way? Or what happened with everybody else's blocks? How do you think the impacts of liquefaction can be reduced? So if we know that this is a major problem all around the world anytime that there's an earthquake, what are ways that we can reduce it? And that is a great scientific thought to be having. Like, how can we mitigate, how can we reduce the risk of liquefaction everywhere that we have sandy soil or soil that can become hypersaturated with water? These are the things that you're going to be working on in this investigation today. And when you're done, you're going to explain what the block represents and what the mallet represents. And then we're going to ask you, like, how could you change the model to test ways to make buildings constructed on sand or mud more stable? Come up with a plan, include a diagram of how your test would work. So there's lots of different options of ways that you could modify this investigation to become an engineering project and figure out ways to reduce the impacts of liquefaction. And that's really the essence of the science we want you to get to. Because when you're all done today, you should be able to define liquefaction and you should be able to model what happens during liquefaction. Enjoy, scientists!